of the neurons of the brain. And it is a rule of three which you have to remember. One is that it has three lobes, anatomical lobes. So there are three anatomical lobes of cerebellum: anterior, middle or posterior, and flocculonodular lobe. There are three peduncles of the cerebellum. So you have the superior cerebellar peduncle, which connects the cerebellum to midbrain. There is middle cerebellar peduncle, which connects the cerebellum to pons, and there is inferior cerebellar peduncle, which connects the cerebellum to medulla. There are deep cerebellar nuclei. There are three, groups of cerebellar nuclei. So what is the arrangement in the cerebellum is there is a gray matter outside, and then there is white matter inside, and within the white matter there are three groups of deep cerebellar nuclei. And these three cerebellar nuclei we are going to talk about, like dentate nucleus, nucleus vestigi, and interposed nuclei. So there are three groups of deep cerebellar nuclei within the white matter. Then there are three layers of cells. So if you look at the gray matter, you would find that there are three histological layers. Like there are 6 histological layers in the cerebrum. There are 3 histological layers in the cerebellum. So starting from the molecular layer, the Purkinje layer, and then the granule cell layer. So there are 3 cellular layers in the gray matter of the cerebellum. Then there are 3 functional divisions, and there are 3 blood vessels which actually supply the cerebellum. There is a superior cerebellar artery, posterior inferior cerebellar artery, and anterior inferior cerebellar artery, which supply the cerebellum. We are going to talk about the structural and functional regions of the cerebellum and their specific connections. We are also going to talk about the neurological loops and circuitry which is present in the cerebellum. So in terms of the function of the cerebellum, as we have said many times before, what cerebellum do is basically it's a comparator. So what it is doing is taking the proprioceptive impulses from the body. So from the muscles, from the joint senses, you get proprioceptive impulses, and then it matches this with the intended movement from the cortex. Once it matches that, it identifies the errors and sends corrective signals back to the cortex. So this is the function of the cerebellum. Cerebellum compares the intended movement with actual movement and corrects for errors as the movement evolves continuously in real time. So this is the major function of the cerebellum. And that's why it is also important in coordination. Any coordinated movement needs to be corrected as it evolves in real time. Yes?
Use the mic for the video.
Sure. Okay, so cerebellum receives information from the motor areas of the cortex concerned with planning and execution, as well as from sensory information which it's getting from the proprioceptive impulses from the body. Using this information, it compares it with the actual motor response and provides corrective input to the motor areas. Now we will talk about a little bit on the anatomical parts of the cerebellum before we start to look into the different types of connections and how it is going to work. So if you look here, you will find that cerebellum has 2 cerebellar hemispheres. Can you make out these?
Yes.
There are 2 cerebellar hemispheres, and these 2 cerebellar hemispheres are joined in the center by a thing which we call as vermis. So vermis is in the center, and there are 2 cerebellar hemispheres. If you look at the superior surface, the surface of the cerebellum, it is run into folds. So like in the cortex, cerebral cortex, you have these folds which are called diaphragm. here these folds are called folium. So you have folia on the surface of the cerebellum. So you see these folds, the small folds on the surface of the cerebellum. These small folds are called folia. You can see the three peduncles here. The big peduncle which you see is the middle cerebellar peduncle. Then this is the inferior cerebellar peduncle, and this one is the superior cerebellar peduncle. The location of the cerebellum is behind the pons and behind the upper part of the medulla. So it is actually forming the roof of the fourth ventricle. So the portions of the pons and medulla which are going to form the floor of the fourth ventricle, on the roof you have the cerebellum. If you cut the cerebellum into half, you are going to look at a tree-like structure. Can you make out this tree-like structure? This tree-like structure is called arbor vitae. It's called arbor vitae. It is going to appear like this because you have gray matter outside and you have white matter inside. So it looks like, you know, a leaf-like or tree-like structure, and this is called arbor vitae. You've got it halves in a sagittal section. The third diagram which you are looking at is showing you the three functional lobes of the cerebellum. We are not talking about anatomical lobes at the moment. We are talking about the functional lobes of the cerebellum. The three functional lobes include the cerebrocerebellum, which is the lateralmost part of the cerebellar hemisphere. This is the cerebrocerebellum. That means it is going to project back into the cerebral cortex. So it is cerebrocerebellum. It is mainly important in correcting and execution of complex movements. So any complex movements which you are doing, the correction of that is done by the cerebrocerebellum. So it is going to project back into the cortex where you have the planning of complex movements. The spinocerebellum, which is the median and the paramedian part of the cerebellum, this is mainly responsible in correction of your posture, your muscles of the trunk, as well as your trunk, any movement which you are performing in the limbs. So the central part is mainly responsible for the head and the trunk, and a paramedian part which you see here is responsible for correcting the movements in the limbs. Then you have this area, which is the flocculonodular lobe, which you see this area like a small bulging area. It's called the vestibulocerebellum, and this vestibulocerebellum is important in correction of balance and equilibrium. So you have three functional lobes of the cerebellum: cerebrocerebellum, spinocerebellum, and the vestibulocerebellum. The cerebrocerebellum is mainly important in correction of complex movements. Spinocerebellum is correcting the muscle tone and posture within the trunk and the head as well as in the limbs. So the median part is for the head and the trunk. The lateral part is of the spinocerebellum is for the limbs. The vestibulocerebellum is important in terms of correction of balance and equilibrium. You also have homunculus, similar to the homunculus which you have for the cerebrum. There is a representation of the body. So this is the spinocerebellum, and you can see the anterior part of the cerebellum is represented, is the area where the lower limbs are represented, while the central piece is representing the head and the trunk, while the lateral portions of the spinocerebellum is representing the limbs. So although it is not that the homunculus here is not that much clear as what you have in the cortex, it is quite fractured here, but you still can make out that the anterior portions of the cerebellum are representing the lower limb. So if you have any damage to the anterior portion of the cerebellum, that would lead to leg ataxia.
Doctor?
Yes.
Is it the same for the legs that are above and below?
Yes. Here what it is representing is that the lateral portion is representing the limbs and the central portion is representing the head and the leg. But here it is representing that the anterior portion of this area is representing the lower limbs. So you have if you have the anterior portion of the cerebellum is going to be affected, you would have the leg ataxia. Okay, now we are going to see some anatomical lobes of the cerebellum. So the first thing which you are going to make out is this fissure. Can you make out this fissure? This fissure is called the primary fissure. An area in front of the primary fissure is called the anterior lobe of the cerebellum. It's not a functional lobe, it's an anatomical lobe. So area in front of the primary fissure is called the anterior lobe. The area behind the primary fissure which you see here is called the posterior or the middle lobe. Some books will refer it as the middle lobe, others will refer it as the posterior lobe. And then you can see a small area here. Can you make out this small area? So this, between this, there is a fissure which is separating this from this large area. So this is the flocculonodular lobe. So there are three lobes: the anterior lobe, middle and posterior lobe, and this is the flocculonodular lobe. You can also have a horizontal fissure which is separating the superior surface from the inferior surface. So this horizontal fissure is only going to separate the superior from the inferior surface. It is not separating the lobes. You can see it here. This is the primary fissure, and in front of the primary fissure you have the anterior lobe. Behind the primary fissure is the posterior lobe or the middle lobe, and then you have this posterior lateral fissure which separates the posterior lobe from the flocculonodular lobe. So you have three lobes, anatomical lobes of the cerebellum. Anterior, posterior is behind the primary fissure, posterior or middle, and then you have posterior lateral fissure which separates the posterior or the middle lobe from the flocculonodular lobe. Now we are going to go and see the internal structure. So what you are seeing is this is the gray matter outside. Can you make out?
Yeah.
So this is the gray matter, and then you have the white matter inside, and within the white matter you can see the deep-seated cerebellar nuclei. So you have gray matter outside, then it's the white matter, and then within the white matter you have these deep-seated cerebellar nuclei. Now, as we said before, there are three groups of deep-seated cerebellar nuclei. If we start from lateral to medial, laterally you see this nucleus which has saw-shaped appearance or tooth appearance. So as it has a tooth-shaped appearance, this nucleus which is on the lateralmost nucleus which you see here is called the dentate nucleus. It's called dentate because it is saw-shaped or it has tooth-like appearance. Within the curve of the dentate nucleus, you see these two nuclei. One is called the emboliform nucleus, the other is called the lobos nucleus, and both of them together are called interposed nuclei because they are close to each other, so they are called interposed nuclei. And the most medial group of nuclei is called the fastigial nucleus. So we start from the medial, this is the fastigial nucleus, then you have the lobos and emboliformous nucleus which are the interposed nucleus, and then you have the laterally the dentate nucleus. Now dentate nucleus is part of the cerebrocerebellum. That means it is important in the role of correction of the complex movements. The nucleus, the interposed nuclei which are which are next to the dentate nucleus, they are responsible for correction of movements in the limbs, and the fastigial nucleus is basically responsible for correction of the movements in the trunk and the head. Both the interposed nucleus and fastigial nucleus are part of the spinocerebellum. So dentate nucleus is part of the cerebrocerebellum, where it is important in correction of the